All right, guys, welcome to class today. I am obviously out of the building here, so you're getting a video lesson. What you should have sitting in front of you right now is a note sheet that you are going to fill in as you watch this video. So make sure that you do that. Pause the video anytime you need to. This also is available on my website, so you can get it at any time. Thank you. Let's begin. All right, here we go. Chapter 5 is about geometry and logic. All right. Before we do anything with our geometry stuff, we need to define a whole bunch of terms. So that's why I gave you guys a note sheet. There's a lot of things to define today. We're going to start with the very basic definition of what is geometry. All right, so we're going to start there so that we can basically build a vocabulary and learn the language of geometry so we can move on with it. All right, right away, here we go. What is geometry? Geometry, if you break down the Greek, geo is Greek for earth, okay, and metria for measurement. So when we talk about geometry, we're really literally talking about measurement of the earth. Okay? Next thing, basic terms that we need to understand. Before we get into basic terms, also understand that geometry is just basically the study of points in space. All right? That's all it is. Just the study of points in space. That's generally what we're going to be doing in this chapter. All right? Basic terms. We're going to talk about points, lines, and planes in the beginning, and then we're going to define some postulates about it. Here we go. What is a point? Okay? A point is just a location in space. That's all it is. So right now, all of you guys can look at 3 feet below my projector, and you know where that is, but that point has no dimension, it has no length or width. You can all tell me what it is, but you don't know how to measure it. Okay, it's just a spot. It's a location in space. That's all a point is. Okay. Ways to label points. Capital letters are what we use to label points. Also, we can talk about points and write out the entire word, point P. So if you need to give a question answer that has, define the point that has 2 lines intersecting, where 2 lines intersect to find that point, you can just write P, point P, if that's the point where they intersect. All right, moving on here. A line. A line is a set of points that extend forever in 2 opposite directions. So here's a graph. I can draw a line on this. And the way to indicate that they extend forever in 2 opposite directions is to put arrows on them. Okay? Also, when we're talking about lines, is we're going to label them. Let's say I get points to this. Let's say I got A and B here. And I want to label this and talk about it in an answer. I would have to say A, B, and then have my line over the top, but also have the arrow symbols on there. All right? That has to be there as well. Okay, so that's what a line is. Moving on here. Now, if I take the arrows off of that, I now have a line segment. A line segment is a portion of a line. Line segments that are congruent have the same measure. So there's a lot of information there. Line segment is a portion of a line, and if I say that line segment, AB is congruent to line segment BC, then they have the same measure. So an example of that, I could say like, well, I have a line that has those 3 points on it, A, B, and C. Okay? And if that's true, and if those 2 things are congruent to each other, the way I mark segments congruent are with those dashes through it. So now I can say that AB is congruent to BC. All right, that's how I would label that. Midpoint of a segment is exactly what it sounds. It's the middle of a segment. Okay, so what it does is actually divides the segment into 2. So I really actually have that drawing right here. B is the midpoint of segment AC. And if you're asked, if you're told, like, if B is the midpoint of segment AC, label the 2 equal parts, your answer would be exactly this. Okay. Next thing, a bisector of a segment. Bisector, that word means to cut in half. All right. Bisectors of segments cut things in half, but instead of saying it's a midpoint, now I got a tool doing it. So I can have a line or a plane that cuts a segment into 2 congruent segments. All right. So that picture could look something like this. I have my point here. Now instead of having a point, I now have a line that goes to that point. I can call this lowercase l. And if I say line L bisects line segment AB, I can say that A intersects at C. I can say that AC is congruent to CB. Okay? Those are the types of questions you're going to have on your homework tonight, so make sure that you understand those things. All right, next part. Example, if F is the midpoint of line JK, so line JK is right here. It says F is the midpoint name two congruent segments. So just like we had before, if F is the midpoint, that means those two things are congruent to each other. So I would write JF congruent to FK. Excuse my writing here, it's a little bit choppy moving the screen around here. All right, next part. Line segment EC is bisected by line segment BD. So bisecting means to cut in half. What's being bisected? EC is what is doing the bisecting. All right, so let's look at the picture that we got. Okay, EC is bisected, cut in half. So then I have two equal parts there by line segment BD. So then I can say, just like before, EA is congruent to EC. Okay. So, different things that you will have to do in your homework tonight. Moving on. All right, a plane. A plane is a flat surface that extends in all directions forever. So I can, if I want to, put those here. Okay. Also notice that there is a cursive M there. That's typically how planes are measured or labeled. All right. So I could write this as plane M if I want to talk about that plane in a problem. Okay. I also can use the 3 points that are on there. I call it plane A, B, C. Okay? All right, so that's a plane, it's a flat surface that extends forever in all directions, and that's how you label it. All right, types of points now. By the way, up to this point, we talked about points, lines, and planes, and now we're going to break down little bits of information here. Collinear points. Collinear points are points that are on the same line, okay? That has the word in there, line. Points that are on the line. So, for example, I can say I got points A, B, and C. And I can call this line AC. I can actually call it line AB as well. And I can say points A, B, and C are all collinear because they lie on the same line. Okay? Non-collinear points are exactly what they sound. They're points that are not on the same line. So for whatever reason, the students always have a problem drawing this picture. All you're going to do is establish a line. So here's A, here's B. And points that are not on the same line are non-collinear, so just put another point that is not on the same line. Then I can say that points A, B, and C are not on the same line. All right? Coplanar points are just like collinear points. Collinear points are on the same line. Coplanar points are on the same plane. Okay? So I can draw a picture of a plane. I can label it M. I can put point A and point B on there. That point. I can say points A and B are coplanar. Okay? Non-coplanar points are points that are not on the same plane, obviously. Now this one's a little bit more difficult because planes forever and ever in all directions. It means anything else that I would put on this flat surface, like even out here, that technically would be on that plane. So what I gotta do is be a little creative. I'm gonna draw a line that intersects the plane and goes through it. Comes out the back. Okay? And then I'm gonna put a point that's off that plane. And I will say that point A is non-coplanar with point, let's say, C. Okay? I don't want to draw that in. So C and A are non-coplanar because that line there goes through it and is not on the plane. All right? Moving on. Okay. So some examples here that you're going to see in your homework. Let me zoom out here. View, zoom. Go 75%. All right, so here we go. What you're going to see in your homework tonight are questions that look like this. Name the following items. And first thing we got here are 2 collinear points. So I can pick anything that are on this line, or any line, and I can say that point A and B are on the same line right here. All right? 2 non-collinear points. So I can say that E and F are not on the same line. Okay? They're not on the same line. They're not collinear. 2 coplanar points. Pretty much any point that's on here, I can say is coplanar. So I can say that maybe B and R. Those are on the same plane. 2 non-coplanar points. Point P up here is that example that I just gave you. It's not on that plane. And let's use another point here. Point P and C are not on the same plane. They're non-coplanar. All right. Postulates now. All right. Sorry. Intersection first. Intersection definition. Let me zoom back in here. Some points that 2 figures share in common. All right. That didn't do what I wanted to do. Zoom. All right. Set of points that 2 figures share in common. Okay? They have to share points in common in order to intersect. So, types of intersection that we have. Number 1, we have 2 lines. there are two lines. Get my notes on there if they're going to be lines. And when they intersect, they share a single point in common, and there it is. Okay, so when two lines intersect, they share a point in common. Okay, next thing, a line with a plane. They can do two things. They can share a point or infinitely many points. Here are the two pictures. One of them we've already talked about. So here's my line that intersects the plane, and they share that point in common there. Or I can have that line be on the plane. Okay? Notice this line here is on the plane. This one goes through the plane, so they share a point in common. So this one they share a single point. This one they share infinitely many points together. All right, moving on. Next type of intersection. Two planes. This one's a little bit more tricky, so bear with me as I'm drawing here. When two planes intersect, they share a line in common. So this is what that kind of looks like. Okay? Here's my plane. Here's my other plane. And that last line didn't look so great. Let me try to edit it a little bit there. Oh boy. Okay, I think you get the idea. There's a plane here, and there's a plane here, and they share that line down the middle when they intersect. Okay? So two planes share a line in common, and hopefully you guys can draw that a whole lot better than I can. Okay? Next slide. Postulates now. Point line postulates. Postulate 1. Through any 2 points, there is only one line because we define lines to be straight. Okay? That's the first one. For any 2 points, there is exactly one line. Next one. What is the minimum amount of points that we need to define a plane? 3 points. If I only have 2 points, then I only have defined a plane. So if I need one more point to define the plane, there it is. And so now I have defined this whole entire flat surface. So 3 points need to define a plane. All right, next. Through any 3 non-collinear points, there is exactly one plane. All right, so that's kind of the same thing as this is here. Okay? So through any non-collinear points, non-collinear points, there is exactly one plane. Okay? Because if that third point is on this line, I've still only defined a line. So it has to be non-collinear. It has to be not on the same line. All right. Next thing. Postulate 3. If 2 points lie in the same plane, so here is a plane, here are 2 points. What can we say about the points between them? So what can we say about all the points that fall in that spot? Well, they're also on the same plane. Okay? Because the line is on the same plane, they're also on the same plane. Okay? Next thing here. If 2 points lie on the same plane, then the line connecting them is also on that plane. That's kind of just restating the same thing again. If 2 points lie on the same plane, then the line connecting them is also on that plane because all the points are also on the plane. All right? Postulate 4, what is formed when 2 planes intersect? Well, we've already talked about that. That is a line that runs down the middle. Okay? Now, you have everything that you need to answer the questions on the homework, all right? The homework is on the board behind me. It's actually right there. I can tell you that you're doing pages 194 to 195, and it's 2 to 28 units. All right, good luck, and I'll see you tomorrow.